Now see a ratio of maximum and minimum intensities in interference pattern. So we know it, intensity I is equal to I1 plus I2 plus twice of under root of I1 I2 cos phi. For maximum intensity, we can write cos phi is equal to plus 1, that means phi is equal to 0. So we can write I max is equal to I1 plus I2 plus twice of under root of I1 I2. We can also write under root of I1 plus under root of I2, that is a whole square. So this is the maximum intensity. Similarly, we can write I minimum, that is a minimum intensity, under root of I1 minus under root of I2 whole square. In that case, we will be taking phi is equal to 180 degree. Now, cos phi is 180, that cos phi, suppose it is a minus 1, so phi is equal to 180 degree. So, we can take the ratio I max upon I min is equal to under root of I1 plus under root of I2 whole square upon under root of I1 minus under root of I2 whole square. So, this is the ratio of maximum to minimum intensity in the interference pattern. Also, we can write the equation related to the amplitude. So, we will be getting R max upon R min is equal to A plus B upon A minus B, where A and B are the amplitudes of the two waves. Here I have not taken the equal amplitudes. Now, we can also write in this case R max upon R min is equal to, that is A plus B upon A minus B. So, if we square both the sides, we will be getting I max upon I min is equal to A plus B whole square upon A minus B whole square. So, this is the one relation also in terms of amplitude. There is also the relation between the intensities of the sources. So, as we know it, I is proportional to K A square, that is I1, I is 1 is equal to this much. So, I2 is equal to K B square, that is the intensity of the first source and intensity of the second source. So, we can write I1 upon I2 is equal to A square upon B square. So, this is the relation for the ratio of the intensities of the light coming from two coherent sources. Similarly, there is one relation also we can utilize here, we can write the relation between intensity and the width of the slit. Suppose you have got the slit like this width is W1 and here is the width is W2. Then you can write here I1 upon I2 is equal to W1 upon W2. So, intensities of the the sources is directly proportional to here the width. So, we can write I1 upon I2 is equal to W1 upon W2. Now, see here, so we have seen all these relations of the intensities. Now, let us take the example when the intensities of the light coming from both the sources are equal, then what will happen the resultant intensity. Suppose you have got I1 is equal to I2 is equal to I naught, then we can write I is equal to I naught plus that is twice of under root of I naught square cos phi, and that can be written twice of I naught plus twice of I naught cos phi. We can take common twice of I naught 1 plus cos phi, and that can be written I is equal to 4 I naught cos square phi by 2, this relation. So, this is the relation also can be used when the intensities of both the sources of the light are equal. So, these are the different cases of the maximum intensity, minimum intensity in terms of the amplitude and in terms of the intensities also here. So, now we will do the expression for the fringe width as well as the graphical relation between the intensity and path difference, or you can say the phase difference.